Okay, so today we're going to talk about Blackboard assignment number 5, which is really just the first lesson in your first unit called Equations, Inequalities, and Complex Numbers. Lesson 1 is going to introduce us to part of complex numbers and really introduce us to what they are, why they're used, and ultimately we're just going to talk about 2 of the 4 main operations that deal with complex numbers for today. So in Blackboard number 5, hopefully you guys have had a chance to print off this PDF. If you haven't, now is a good time to pause the video. Make sure you print out or have a piece of paper to take notes on what Blackboard assignment number 5 is all about. And the next time we get together in class, we'll go over any questions that you guys have throughout this video. So to start out, it's pretty well known that the square root of any real number x is never negative. Okay? So if you square root a real number x, as long as it's a real number, you're never going to have if you square, not square root. If you square any real number, you're never going to get a negative number. So let's just look at a couple examples. If I square negative 2, I know I'm going to get a positive 4. If I know I square positive 5, I know I'm going to get a positive 25. So no matter what the number is that you're squaring, you will never get a negative number out for your answer. So what happens if we have the equation x squared is equal to negative 1? Let's say, for example, this is what we're looking at. X squared is equal to negative 1. How is it possible that we do have something that we square, or is it possible that if we square something that we are going to get a negative number out? Is that ever possible? And if it is it a real number? So what we're going to move on today is the equation does not have this equation right here. The x squared is equal to a negative number, because we have always been conditioned to know that the square of any real number is never negative. Therefore, when it does happen, if you were to have something that you square to get a negative number, we know that this equation does not have a real number solution. So if this happens, we know right off the bat that we do not have a real number solution. So to solve this equation, mathematicians created an expanded system of numbers using what we call the imaginary unit. And we actually use the imaginary unit, I, to represent imaginary unit. And I is not a variable. Actually, in this case, that little italicized I is going to represent a number, and we'll get into that as we get into these notes. So to solve the equation, we had to create a completely different system because the real number system does not allow us to square anything to get a negative number. So we have this new system called imaginary numbers. So the imaginary unit is defined as I, so it's not a variable, it's actually a value, is equal to square root of negative 1. Or in other words, if we square both sides, I squared is equal to negative 1. So if we square I, we get I squared. If we square the square root of negative 1, we get negative 1. They cancel each other out. So I is not a variable in this case. It is actually a value that we're going to use to represent our imaginary unit. So the imaginary unit, I, can be used to write the square root of any negative number. So down here I have a couple properties that are going to be particularly useful as we start building on this concept of complex numbers. So in number 1, the very first property, and we don't have to remember the exact property. I'm going to show you some examples that put the properties to use, but you don't have to remember the exact property. So if r is a positive real number, then the square root of negative r is equal to I square root of r. So a good example that represents this, if I have the square root of negative 5, I can always rewrite the square root of negative number by taking the I out, because remember, the I basically represents the negative inside your square root, okay? So if I take the I out, I'm basically taking the negative out inside my square root, and I'm left with the positive version of that number. So square root of negative 5 is the same thing as I square root of 5. The I represents the value of square root of negative 1 and allows me to pull that negative out. Number 2 is adding on to the very first property, and it follows that if I have I square root of r and I square this, I'm actually going to get negative r back out. So what does that really mean? Well, that property is really just telling us that I square root of 5 squared, I square root of 5 squared, is really just squaring both of these pieces, the outside piece and the inside piece. So this is no different than taking I and squaring it times square root of 5 and squaring that. Okay? When I do that, I squared, I know I squared is the same thing as negative 1. So I get negative 1 times, well, we all know that if we square the square root, we're just left with the inside number. So negative 1 times 5 gives me negative 5 for that answer. So that's the same thing as the negative r value inside, which is the negative 5 of the 5 that I was originally given. So those are just a couple properties that will always hold true with complex numbers, the imaginary unit. And we're just going to build on that. Like I said, you don't have to remember those properties verbatim, but it is something that you're going to want to know in the back of your head as we start working with these imaginary units. So let's look at example 1 together. In example 1, they're wanting us to solve the following quadratic equations. Quadratic because we know that our x in this case is x squared. So let's look at letter A. 7x squared is equal to negative 49. If I wanted to solve this equation, I'm looking for values of x that if I plug in, it's going to make this statement true. So the first thing I'm going to do is I'm going to work backwards to get x all by itself. So because I'm working to get x all by itself, I'm going to divide both sides by 7. If I cross both 7's out, I'm left with x squared is equal to, well, negative 49 divided by 7 is negative 7. Now in this case, if I had gotten this before, if I square rooted both sides, I know I would have no real solution, and that's actually true. There is no real solution. However, now that we know what imaginary numbers are, I now can take the square root of a negative number because I know about the imaginary unit. So I can come up with some type of solution, even though it's not a real number solution, I still can get an imaginary answer. So if I square root both sides, square root of x squared is obviously x. I always get two answers. Whenever I square root, I get a positive and negative version of the square root of negative 7. Now, just so that we're all clear, we do not want to leave our answer this way. We don't want to leave the negative inside our square root. So we're going to actually go one more step, and we're going to pull that negative out. And how we do that is that little imaginary I unit. That I means we pull the negative out, and we're left with the square root of 7 as our final answer. Moving on to example 1, letter B. So we're going to solve this quadratic equation. So the first thing we're going to do is we're going to start getting all the numbers on the same side of x away from x. So I'm going to start by adding 5 to both sides. So I get 3x squared is equal to negative 24. Just like I did in letter A, I'm going to divide both sides by 3. So I'm left with x squared is equal to negative 8. Just like I did in letter A, I'm going to square root both sides. When I square root both sides, I get x is equal to positive and negative square root of negative 8. And we know we can't leave our answer with a negative number inside our square root, so we're going to use our I value, plus and minus I square root of 8. And at this point, we know that we can actually break down the square root of 8 a little bit further. We can simplify it by pulling out a perfect square. Since the square root of 8 is the same thing as square root of 4 times the square root of 2, my final answer will be plus or minus I 2 square root of 2. And I know I'm kind of running out of room here, but I really wanted to show you this because the square root of 4 is 2, the square root of 2 stays the square root of 2. And the way that we write this in terms of imaginary numbers, and I'm going to draw this up here, so I apologize for being all over the paper, but I want to make sure that I point this out. You don't want to leave your answer like this. We actually want to pull out every whole number out in front of the I. So the way you would want to write this is plus or minus 2I square root of 2. And that should be your final answer, and that's how you want to make sure that you write your answer, especially if you are simplifying square roots. Okay, so at this point, we're going to kind of pass on by a couple things. I have a couple problems here, letters C through F, that we're going to work on in just a little bit. These problems are just extended problems that you guys can come back to and make sure you fill out. We'll go over these answers together the next time that we're in class. But for right now, we're going to actually continue on with the notes, so make sure you star and highlight that you're going to want to come back to those 4 problems. And we're going to continue on with our notes and building on the imaginary unit. So the imaginary unit can be used to create complex numbers of the form a plus bi. So complex numbers in standard form is the number a plus bi, where a and b are actual real numbers, okay? They're actual real numbers. So complex numbers are basically numbers that include imaginary numbers, okay? They're just called complex. So the way that we're going to fill this in, a complex number is of the form a plus bi. A and B basically stand for any real number. I, again, is not a variable. I represents the imaginary unit, which we all know to be now the square root of -1. So that's just something to keep in mind. So these complex numbers can be broken up into 2 ideas. The first is complex numbers include real numbers. Okay? So complex numbers actually include real numbers. And the real numbers that they include is the form a plus 0i, because obviously 0 times anything is going to be 0. So real numbers is actually part of your complex number. So some examples of real numbers are whole numbers like 5. They can be fractions like 1/2. They can be square root numbers, or they can be negative numbers. So those are all examples of what real numbers are. Complex numbers also have another part to them that it's called imaginary numbers. I'm just going to put numbers like this. And imaginary numbers is of the form a plus bi, where b is not equal to 0, like they were for real numbers. And some examples of imaginary numbers are 4 plus 7i, that's actually an imaginary number. 3 minus 2i, so it can be plus or minus. So those are some examples of imaginary numbers. And imaginary numbers can be complex, where they've got a real number part and an imaginary part. But imaginary numbers can also be what we call pure imaginary numbers. And pure imaginary numbers are basically imaginary numbers that do not have a real number part. So some examples of pure imaginary numbers is an example like -3i. It has no real number part out in front. Or something like 8i. So that kind of gives you the breakdown and the family tree, so to speak, of what complex numbers are. And although I is not a variable, it behaves like one when you're adding and subtracting. So we can manipulate these imaginary numbers. We can add, subtract, multiply, and divide, although we're just going to talk about adding and subtracting today. So I, even though it's not a variable, it can behave like one. So it's got the similar properties when we're adding and subtracting complex numbers. So moving on to example 2. Here's an example, example 2. So in example 2, they want us to add or subtract the given complex number. Okay, so when we do that, we have A and B that we're going to talk about. So the first is, let's look at letter A. In letter A, we have the complex number 3 plus 2i plus the complex number 1 minus I. Okay, so both of these are complex numbers. We have a real part and an imaginary part, so we know we have an imaginary number that we're actually adding here. And when we do this, you got to be careful, because I know it looks very similar to what you would do when you FOIL numbers. I know that that's something that looks very similar, but make sure that you are paying attention to what operation is happening between the parentheses, okay? So how we're going to add these numbers is we're going to take the real number parts and we're going to add them. So 3 plus 1 obviously gives us 4. And we're going to then add our imaginary part, which is 2i plus a negative 1i. So 2i plus a negative 1i gives us just a positive 1i, or 4 plus I as our answer. In letter B, here we're subtracting, so we got to be extra careful about those double negatives. So in this case, we have 6 minus 1. So that negative actually gets distributed. So we could, if we wanted to, rewrite this as minus 1 plus 2i. We have to distribute that negative. So when we add these, 6 minus 1 gives me 5. Negative 2i plus 2i actually cancels out, so we no longer have an imaginary number. And we end up with a real number answer, which is just 5. So at this point, this pretty much sums up our Blackboard assignment number 5 notes. We have a part here that's dedicated to you guys working through a couple more problems together. We'll go through those as well the next time that we're in class. And then you have a bottom part that is called Now You Try. And that has 3 separate parts that have questions for you where it requires you to show your work. So make sure that you read through those directions. Write down any questions that you may have so that the next time we're together in class we can go over them, and make sure that you understand exactly what Blackboard Assignment 5 is so that we can move on to the next part of the complex numbers, which is multiplying and dividing.